Okay, kids, this is day 10, breaking down 10. Miscellaneous. This is all the weird stuff, all the things I couldn't quite put in one other area of all the things that you could see as a part 2, part 3, or part 4 question. So we'll get through this rather quickly, but if this is your first one of these, you probably want to see the other ones, especially the trig and the logarithms ones. Those are kind of difficult. Those are very lengthy. But if you need to know where to find all of my stuff, you can simply go to MrKrausemath.com. There it is. You'll find my ugly mug right there. If you don't have my flashcards yet, by the way, if you've already heard this lecture and speech like every single time, by the way, if you didn't hit the subscribe button, hit the subscribe button, hit the like button, hit the comment button. I don't care what you do. Oh my God, look at this. Look at this. 8 days, 13 hours, 52 minutes to your exam. Kind of scary. Okay, it's not that scary. You guys are good. You guys are good. Okay, what am I doing? So, up. If you don't have my flashcards, get the flashcards. They're very simple. If you don't know these things will haunt you. They'll be very, very difficult. For example, do you know what cosine squared plus sine squared is? It's 1. Got it. If you see the word forces, what's the first thing you're going to do? Oh, you're going to draw a parallelogram. One side longer than the other. What's the formula for the period of a trig curve? Period 2 pi over b. Ooh, nailed it. These are easy. Log of x plus log y. Oh yeah, that's log of x times y. I remember that. Oh my gosh. So see what you can do. Oh, what are you going to do with this one? Make the bases the same. So you're going to make this 2 to the 4th times x plus 3 and 2 cubed. See? 2 to the 4th is 16. 2 cubed is 8, and then you set the exponents equal to each other. But if you don't know these things, man, are you going to be in a lot of trouble. Please, please, please download the flashcards. If you come to my website, come over here. These are all the Algebra 2 exams broken down for you, just for fun, all for you. Then we're going to go over here to Algebra 2 trig topics. Now, these are ones I created on my own. These are all just more videos, and you can click on the notes. You can print those. Lots of crap, lots of log questions, and if you don't want to, click on the video on how to see on the solutions. Got trig graphs, trig formulas, area of the triangle, quadratic formulas, all kinds of stuff in here. So if you know you need help, come here, get the document, do some review. I also took, and that's what we're working on right now, all of the topics on old Regents exam. You'll notice right now we're on this last one right here, video coming soon. That's what we're working on right now. So when you go here, you probably won't see that, but those are all the topics, big topics, and some of them are just a couple of problems. But I'm telling you, the trigonometry one is huge. The logarithm ones is huge. Regression, kind of big. Factoring's got a lot of stuff in there. Probability's got a lot of stuff in there. Solving inequalities is almost every year on the test. You want to make sure you know how to do those problems. There's always some tricky stuff with that, okay? All right, let's get ready to roll. We will start with this first problem. One of my flashcards says, when you see the word something funky's going on. Okay, when you see the word is subtracted from, what does that remind you? What are you going to do when you see the words is subtracted from? If you remember correctly, you're going to take this one and you're going to subtract this one. You got to do it backwards. So what we're really going to do is take 2x cubed plus 3/4 x squared minus 2/9 is minus, now we're going to subtract off this whole thing, 4x cubed minus 5/8 x squared plus 7/9 x. That is some terrible penmanship. I got to work on that. I'll slow down a little bit. It's been a long day. I just got home from work. I want to eat dinner, but I haven't had dinner yet. I want to eat, and then I'm going to relax tonight. But I want to get this done first for you guys. Now, by the way, 2/9. 2/9. Now we have to distribute. There's the tricky part. You got to distribute that negative to everybody. So minus 4/3 x cubed plus 5/8 x squared minus 7/9 x. And now you just put all the stuff together. I can put 2/3 and minus 4/3. Now I'm assuming you can use a calculator to get that. That's, let's see, 6/3. That's 2/3. So 2/3 x cubed, and then 3/4 minus or plus 5/8. So 3/4 is 6/8. So that's be 11/8. So that's plus 11/8 x squared. And then this should come next, actually. Minus 7/9 x minus 2/9. And there it is. That's it. Bodied. All right, kids, here we go. If you don't know that this big E right here just means sum up, otherwise known as add. But we got to figure out what to add. Now remember, our A values are going to run from 1 to 4. So all we got to do is plug in for the A. So I plug them in. I go x plus, oops, I said plus, I meant minus. X minus 1 squared. Well, that's x minus 1. X minus 2 squared. Well, that's x minus 4. X minus 3 squared. X minus 9. X minus 4 squared. That's x minus 16. Now, I stop at 4 because the top number is 4. I got to stop there. That's what you got to do. And now the big E says add them all up. Okay, no problem. 4x minus 20. Ka-ching! All right, so if you forget the I circle, all right, let me just go through the I circle the way I teach it. I to the 1 is just I. Opposite that over here is I cubed, and that's equal to negative I. I squared is equal to negative 1, and opposite that is I to the 4th, which is equal to positive 1. Now you'll notice, I hope you notice, that this is just the negative of this, and these two are just negative of each other. Now, if you can't remember that, that's okay. Hopefully you have this calculator because it'll help you whatever. But you have to show work. It's a 4-point question. You have to show work. So you have to come off to the side and say, okay, I know I to the 8th is equal to, and it's equal to 1. But if you don't remember that, you come over here, you go, I raised to the 8th, ka-ching, 1. And then we got I to the 6th. Now, I to the 6th, if you don't know, is equal to negative 1. Now, by the way, I to the 4th, if you have 4 i's, let's go 1, 2, wait. This is I to the 1. 1, 2, 3, and there's I to the 4th. So I to the 4th is there. I to the 5th would be here. I to the 6th would be here. You just count. But if you don't know that, you just come over here. You go, raise to the 6th, and it says negative 1. All right, so now I know that this is x times 1. Got to show your work. Minus y times negative 1. Put things in parentheses when you substitute. This is just x, and this makes plus y. One of my flashcards, oh my God, it's going to be a resounding theme. You're going to be like, oh my God, I'm so sick of hearing the words flashcards, 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 flashcards. Get the flashcards, study the flashcards. If you walk in, I'm telling you right now, if you walk into this exam knowing those flashcards, and I'm talking to you, yeah, you right there looking at me. No, quit smiling. No, seriously. I'm serious, man. You better stop. All right, that's better. Tell your mom behind you to stop making funny, nice faces. Okay, you got it? If you study those flashcards, you're going to walk in with such swag. You're going to be like, dude, I'm going to rock this test. If you don't know those flashcards, you're going to walk out going, dude, I wish I would have rocked that test and I wish I would have studied the flashcards. I'm telling you, they're huge. Huge. They're going to be so freaking helpful for you. One of my flashcards says, what do you see? What do you do when you see the words varies inversely? Oh yeah, that's the formula x times y is equal to x times y. Now, I don't really care what the letters are. I can say p times q times p times q, whatever. In this case, it's p. Oh, this is p and q. In this case, it's p and q. So instead of x and y, I might write p times q is equal to p times q. Well, what do we got? We got 25 when x is 6. 25 times 6 is equal to, determine q when p is 30. Okay, p is 30 times q. Got to find q. Well, this is 150 equals 30q, so q equals 5. Can't get any easier than that. Let me do one more, and then I will take a break for a second. All right, we got more I stuff. And it's going to be, I could have put these together. If you want to go through and do all the I stuff, go through and do the I stuff. Oh, wait a second, it's calling me. It's calling me saying, Mr. Krause, drink me, Mr. Krause. I'll bet you guys are sick of watching my videos. Almost as sick as I'm at right now. I'm making them. I'm ready for summer. Anybody got 1 foot out the door? It's like, here's the door. By the way, I'm a freaking penmanship. I got 1 foot out. And I got 1 foot in. You guys got to bring that foot back in and study for a few more weeks. Or 1 more week. 1 more week, study. All right, we're going to distribute. So you get 2xi squared minus 8xi cubed. And now I'm going to not waste your time. I squared is -1, so this is 2x times -1. You should write off to the side here. I squared equals -1. I cubed, we just went over it, is equal to -I. So I'm going to replace minus. Now notice I'm doing it using parentheses. I always have one kid that'll do this. Oh yeah, I remember that's -I. And then they'll put a -I there and not know what to do. It's not -I, it's times -I. That's why we substitute in using parentheses, so you don't think there's a subtraction there. All right, so this thing becomes -2x. Now this negative and this negative make a positive, because all this stuff here is being multiplied. So plus 8xi. Now when it says put in a plus bi form, it should be the thing without the I first and the thing with the I second. All right, I'll be back. I love you, man. I just love. Y'all didn't see nothing there, did you? It's just my coffee, man. I love my coffee. Oh my gosh, I love my coffee. Okay. Somebody one of those ones, there it goes. Yeah, all of a sudden it's just going to take off. Okay. Okay. So let me talk to you about something. If you see the area, if you see the equation for a circle, you see x minus 5 squared plus, and now you're like, this has nothing to do with a circle. I know. I'm not stupid. I might be old, bold, bald, and ugly, but I'm not stupid. Y plus 3 squared equals, I don't know, 25. If I asked you questions about this and I said, okay, what is the center of this circle? You would say, oh, the center comes right here and it's +5, -3. I hope you would tell me that, and that the radius is 5, because it's, right? If I gave you a parabola in its vertex form, parabolas, hopefully you've seen the parabolas in the vertex form, is equal to x minus 2 squared plus 3. And I asked you, what's the vertex? The vertex would be 2 positive 3. Because just like in that last with the circle in this one, anytime you take numbers out of the parentheses, they come out with an opposite sign. So in this case, this is a normal parabola, but it's been moved to the left, excuse me, this is -2, so it's been moved to the right 2, 1, 2, and up 3, 1, 2, 3. So this parabola would move right 2, up 3. And that's what we got here. Basically, that's what we got here. This is a shift left 1 and up 2. Now you have to show work. That's part of your work. Left 2, left 1 and up 2. So that's what our transformation is. Left 1, up 2. So we're going to take all of these points. Wait, this point, left 1, up 2. This point right here, left 1, up 2. And then this point right here, left 1, up 2. Take all of the good points that are on this graph. There's one right there, left 1, up 2. And this point right here, left 1, up 2. This one here, left 1, up 2. And you just draw it in. That's it. Please be neat. Don't be a slob. Nobody wants to see a slob. Oh my gosh, more I stuff. Again, I know this seems really scary, this a plus bi form. All that means is the thing without the I comes first, the thing with the I comes second. It's not a big deal. Can't do anything with 4xi, it's just 4xi. I'm not going to go over to the calculator every time for this. If you remember, I to the 8th is really equal to 1. So this is 5y times 1 plus 6x. Now if you remember, I cubed, here it is again, it's -I. Calculator will do that for you. Plus 2y and I to the 4th is 1. Notice every time I substituted in for the I did so using parentheses. Okay, it's very important. So this is just 4xi. This is plus 5y. This is going to be minus 6xi and plus 2y. Now, since the thing with the without the I has to come first, we're going to put the y's together. So we get 7y minus 2xi. Now, I'm going to show you something kind of cool. I know you guys are going to think, man, this is some sweet stuff, man, sweet. All right, we're going to do this. We're going to rock this, because if you get a little math, now this isn't bad, but this is another thing that you can do. So here we're going to go over to our calculator. I'm going to say, hey, calc, Hi, calculator. I'm here to see you again. And we're going to take any number. We're going to store it in for x. I always pick weird numbers. Somebody asked me that on a comment one of my times. Do you always pick weird numbers or can I pick normal numbers? Yeah, you can pick normal numbers, but since the calculator is doing it for us anyway, what difference does it make what number you pick? And it runs less risk of having problems. I just pick usually just two positive numbers, and I'm going to store that in. And then I'm going to type in what I got. 4xi. 4 times x times I, plus 5y I to the 8th, plus 5, forgot the plus 5 times y times I to the 8th. It's getting old already. Plus 6x I cubed, plus 6 times x times, see how I'm in exponent mode? I gotta get out of that. Plus, gotta be careful the way you type in. You know, sometimes if you don't get out of exponent mode, you all type in weird stuff. Like I was just doing 6 times I think it was I cubed, wasn't it? I think it was I cubed. I hope it was. And we'll get out of exponent mode. I cubed. 2y I to the 4th. 2 times y times I to the 4th. Now, yeah, this is time consuming. I got a little bit of a problem because I forgot the plus here. That would be a problem. After you type it in, make sure it looks exactly 4xi, 5y I to the 8th, 5y I to the 8th, plus 6xi cubed, plus 6xi cubed, plus 2y. Okay, so there's what you get, 37.8. That's crazy. But now I go over to my calculator. I'm going to type in 7y minus 2 times x times I. And you hit enter. Oh, look at that. It's exactly the same thing. Just saying. You can use it. Use it as a tool. Sum and product of the roots. A 2-point question on a Regents. It should be very easy. These are 2 flashcards. What is the formula for the sum of the roots? What is the formula for the product of the roots? The sum of the roots is negative b over a, where this is a, this is b, and this is c. So the sum of the roots is negative b over a. So that's negative 1 over 12. Done. Product of the roots. It's c over a. Okay. Negative 6 over 12. It didn't say simplest form. I'm done. Problem's over with. Gotta love those problems. In an arithmetic sequence, and I probably should have done a whole video on arithmetic sequences and geometric sequences, but again, if you need assistant, did I do arithmetic sequences? I did not. But if you need help with arithmetic sequences, come over here to my Algebra 2 topics, and you'll find that I have a thing about arithmetic sequences somewhere. There it is. There's a whole lesson on arithmetic and geometric sequences right there for you. So why don't you try that? Oh, okay. By the way, there's simplifying complex fractions. That's kind of cool too. Anyway, here we go. A to the 4th is 19, so I'm going to write a line for a to the 4th. And it's 19. This is a to the 5th. This is a to the 6th. And this is a to the 7th. By the way, if you're just copying me, you're a loser. And I don't like you very much. So pause the video. Do the damn problem on your own. Ooh. Yeah, I said it. What are you going to do about it? You can't do nothing. You're behind a camera. You're not even behind a camera. Anyway, do it on your own and come back. Try it on your own. You need to try these problems on your own. I'm a trained monkey. I've been doing this for 20 years. Not drinking coffee for 20. Oh, yeah. I'm like really, really old. I'll be 50 in a couple of years, so I'm getting there. 31. There it is. So what we want to do is we want to figure out, okay, what do we have to add to here once, to here twice, to here 3 times? I got to add something 3 times to make up this difference. Well, that difference is 12. And I got to add something 3 times. Wouldn't that make sense? I add 4. If I add 4, I get 23. If I add 4, I get 27. And if I add 4, I get 31. So my common difference for my arithmetic sequence is 4. Now, one of your flashcards. Oh my forgot, hadn't said it like for like ever, so I had to say it like there for you, you know, is what is the arithmetic sequence formula? It is not on your formula sheet. Yes, it was on the Common Core Regents exam, which you took a couple of weeks ago and probably didn't do very well on, but it is not on this one. So we have to use a sub n is equal to a sub 1 plus n minus 1 times d. Now to find a sub 1, there's two ways. One, I can just keep subtracting 4. So I get 15, and then 4, that's 3. I get 11, and then that's 2. And then 4, I get 7. Oh, okay, so I just go 7 plus n minus 1 times 4. My common difference is a sub n. And you probably should clean this up, but actually this is good enough. You could do that. Or you could do this. You could say, okay, I know a sub 4 is 19. And by the way, this works if they're really small like this, but if they said this was like the 83rd term, you're like, I'm not going back. I'm not subtracting 83 times. If this was like, you know, if that was a sub 83 was 18, we'd have to do it this way. And here's how it works. You say, okay, I know a sub n, we're going to call this a sub n, is 19. And we don't know what a sub 1 is, but we know that the n is 4. Here we're going to use 4. So 4 minus 1 times d, which is 4. So this is 19 equals a sub 1 plus, and 4 times 3 is 12. Subtract 12, I get a sub 1 equals 7. So if you have to do it that way, you can't just keep subtracting because you're way up in the list, right? Just do it this way. But there's the answer. And by the way, you really want to check this answer. You don't want to just rely on the fact that, oh, I think I got that right. You really want to check this answer. So you come over here and you say, okay, I'm going to check it using the one they gave me. They gave me this one. So n is 7, so a sub n is 31, is equal to 7 plus 7 being the number we came up with at the beginning. N is 7. 7 minus 1 times 4. This is 31 equals 7 plus, now this is 3, this is 6. 6 times 4 is 24, and those add up together. We're getting there, kiddies. We're almost halfway through. It's going to be a quick one. Much quicker than last night. Last night's was 2 hours. So we have to do g of 10. Gee, this is going to be fun. Notice 10 is going in for x. We're going to go 10 in for x. So this is going to be a times 10 square roots of 1 minus 10, and that whole thing squared. Well, let's take care of all the crap that's inside the parentheses first. So this is equal to 10a times the square root of negative 9 squared. The square root of negative 9 is 3i squared. Okay, now I just square everything. So 10 squared is 100. A squared is just a squared. 3 squared is 9. And I squared is just I squared. But don't forget, I squared is really negative 1. So this becomes 100 times 9 times negative 1, or negative 900 a squared. Okay, I'll be back. I know, I probably said this a million times, but the reason I have to pause is so that at some point my audio and video get out of sync if I wait too long. It's just an issue with the computer. It says determine the sum of the first 20 terms dictated by this sequence. Now they didn't tell us if this is an arithmetic sequence, which means we're adding, or a geometric sequence, which means we are multiplying. That's a multiplying symbol. Really terrible. So we got to see. Can I multiply something by 5 to get 14? I can, but it's really stupid. So maybe I'm going to add 9 and then add 9 and then add 9 to get here and then add 9. So it looks like my common difference is 9, making this an arithmetic sequence. So we're going to use that formula. A sub n equals a sub 1 plus n minus 1 times d. Well, this is easy. This is simple. A sub n is equal to, we already know what a sub 1 is. It's 5. It's sitting right there. A sub 1, 5. They told us it was 5. Plus n minus 1 times 9. There's the formula. But that's not what they asked. They said determine the sum of the first 20 terms of the sequence. Now, oftentimes they'll, especially in order to trick you, they're going to want you to do this using a sigma notation, this fancy E thing, right? And that's what we're going to do. Now, you certainly could sit there and add them all up, but if they said 200, you'd be in trouble. So what we do is I found that arithmetic sequence, and a lot of times they'll also say find the arithmetic sequence, then find the sum. So you just got to be careful. So, excuse me, we're going to use the sigma notation, n equals 1 to 20 of 5 plus n minus 1 times 9. And that's all I got to do. That'll add up all of them. So I come over here to my calculator. By the way, the sigma's right here in this crazy button above the times. Hit that one. And it's over here. And enter. I'm going to use n, 1, 1, 20. And then don't mess with these parentheses. Don't touch those. Don't even use those parentheses. They don't exist. You create your own. It's 5 plus parentheses n minus 1 out of those parentheses times 9. Enter. 1810. There it is. 1810. Oh, sum and product of the roots again. You can't talk about the sum and products of the roots until you have it as a quadratic equal to 0. So you have to bring those things over first. And then you got to go back through. Excuse me. Sum of the roots is negative b over a. Product of the roots is c over a. Guess where I learned those, man? Flashcards! Did you not forget where they just go to the beginning of the video, go to Mr. Krause about math, hit home right there, boom. It will literally take you 5 seconds. You log on, if you have a Google or Facebook account, everybody's got one of those. You log on, you just follow these very simple directions. They are absolutely free. I have made them for you. You don't even have to do the work. Thank you. You're welcome. There's a donate button somewhere on my page. Click it. Give me $5. Give me $10. Give me nothing. I don't really care, actually. I appreciate the help. I love you guys having here. I love helping you. But, you know, I could use a new coffee cup. This one's ugly. I'm sorry, baby. Crap. We're still recording. You guys are going to think I'm weird. You already don't. All right, negative b. Since b is negative 11, negative b is 11 over 3. Boom, done. Bodied. By the way, does anybody say bodied except in Hilton? Because I think it's the dumbest thing I've ever heard, but now I'm in a bad habit of saying bodied. I actually had a girl wrote on her test, bodied. I loved it. Like she got it wrong, and she's really smart and probably going to get 100, but it was funny. C over A, 6 over 3. You don't have to write it as 2. It didn't say in simplest form. I'm done. Problem's over with. Let's go. Now this problem, it says they're trying to get you to kind of think a little bit, but I come over here and I say, okay, I to the 13th is... I'll remember. Anybody remember? I mean, I do. It's just I. But you're going to go I to the 13th. Enter I. So this is just I. Now I'm going to do I to the 18th. 18, negative 1, minus 1. Now I'm going to do I to the 31st. Wow, this is a tough problem. I don't know if they put these problems on there anymore, but maybe. Negative I minus I plus n equals 0. Well, this is positive I and negative I. They just go. So what I end up with is negative 1 plus n equals 0. So n equals 1. Could you check that? Oh, I'm glad you asked. You were just thinking, God, I wonder if I could check that. I to the 13th plus I, let's do it this way. To the 18th plus I to the 31st plus 1, because that's what n was. 0, done. Yay. 14 Find the third term in the recursive sequence. Now, I'm going to do this two different ways. I'm going to do it the hard way, and then I'm going to do it the easy way. Recursion's really simple. It just says do something with the one previous term. You're going to have to, I give you a starting term, and you do something with it. Okay? It's like seed money for a business. So my first term is a sub 1. It is 3. I want the third term. This is 1. This is 2. This is 3. So this is the one term I want. So a sub 2 is equal to 2 times the previous term minus 1. Well, that's 3. So 2 times 3 is 6, minus 1 is 5. A sub 3 is 2 times the previous term, which is 5, minus 1. So that's equal to 9. And so your answer is 9. That's it. Now, I'm going to show you using the calculator as well. And here's how this works. You just type in a 3 and you hit enter. And the formula for this says, over here it says 2 times the previous term minus 1. So 2 times, and you have to hit answer, control answer. It's got to say answer here, minus 1. And you press enter. Oops. Oh, I forgot the minus 1. Oh, now it's going to be all kind of messed up. So there's 3. 2 times answer minus 1. Enter. 5. Enter. 9. Enter. And I can just go all day. That's what they all are. I can just keep going all day. If they ask for the 43rd term, there it is. Whatever. All right, let's keep moving. Cube roots. You have to remember when you do a cube root, the cube root of a cubed is a. It takes 3 of these to get 1 out. Okay? The square root of a squared is also a. It takes, really there's a 2 here. It takes 2 of these. These have to match. So, let's get rolling. By the way, you can take the cube root of negatives. Like the cube root of, I don't know why that happened. The cube root of negative 8. Negative 2. The cube root of negative 125. So you can take the cube root of a negative. So, here's what we got. In the numerator, I've got the cube root of a to the 6. Well, that's 2 groups of 3, so that's a squared. There's 3 groups of 3 here, so that's b cubed. All over, what's the cube root of negative 64? It's negative 4. Mathematicians will tell you never to leave a negative in the denominator. So just throw it out front. If you don't know, just throw it out front. A squared b cubed over 4. Done. All right, area formula, or the circle formula. I talked to you about this before. The formula is this. It's x and the center for the x plus, everybody forgets that plus, y and the center of the y squared, don't forget these squares, is equal to the radius squared. Center goes in with opposite signs. So even though that says minus 5, we're going to put it in with plus 5. Because remember, when they come in and out of parentheses, they come out backwards. This 2 is going to go in as a negative 2. So that's the easy part. The only hard part about this problem is finding the radius. And then we're going to get this kid. Well, it's 1, 2, 3. It looks like 3.5 is the radius. I'll come over to my calculator. I'll go 3.5 squared. I get 12.25. No, right, 12.25 there. And you'll be wrong. Wrong. You can't pick an arbitrary point. You have to pick, and there's got to be a reason why they gave you this point right here, right? So here's how it works. What you do is you just make a triangle. Because our ultimate goal is to find this distance right here. Right here, this purple line. I want to find out what that length is, because that's really a complete, full, and very accurate radius. Well, I've created a right triangle. All I got to do is the Pythagorean theorem. This is 3. This is 2. So 3 squared plus 2 squared equals my radius squared, because I'm going to call this the radius. So radius squared is equal to 9 plus 4, which is 13. Now, don't go any further than that. Remember, on the right side belongs the radius squared, so I just need to put a 13 there. Write the quadratic equation such that the sum of the roots is negative 6 and the product of the roots is negative 27. When they ask you to write the quadratic equation, this was a stickling point, and I really hated grading this problem last year, the year before, whatever it came up. you have to write equal to 0. An equation is something that can be solved. It didn't tell you to write a function, so I'm not necessarily a big advocate of that, but when you're done, it better say equal to 0. So we know we got to write something like ax squared plus bx plus c equal to 0. So our goal is to find a, to find b, and to find c. We know two formulas. Our two formulas are negative b over a and c equals, we'll go with p, product equals c over a. And then you kind of get stumped. Now you can play around with it, but the easiest thing to do is just make a equal to 1. Just going to make a 1. Make our life easy. So if a is 1, and I know that the sum of the roots is 6, and I make a 1, this becomes negative b over, a, but a is 1. Well, what is negative b over 1? It's really just negative b. So I end up with 6 is equal to negative b. But that's not what I want. I want to know what b is. So I divide by negative 1. Divide by negative 1, and I get b is negative 6. Then I come over here and I say, okay, the product of the roots is negative 27. That's equal to c over a, but a is 1. So in this case, I end up with negative 27 is equal to c, and therefore, this is negative 27. Now, don't forget to write the quadratic. It's x squared minus 6x minus 27, and if you do not write this equal to 0, it will be wrong. I'll be back. All right, kiddies, here we go. Inverses. Wait, did you not know that was an inverse? This is something you need to know. That says, what is the inverse function? Oh, the first step in finding an inverse is switching the x and the y. So I don't have a y. Oh, yeah, you do. Remember, f of x is really equal to y. So this is y equals x squared minus 6. We're going to switch just the x and y, nothing else. Don't bring the 2 with that x. So this becomes x equals y squared minus 6. Well, now we have to solve for y. So first step, solve for x and y. Switch x and y, and then solve for y. So x plus 6 is equal to y squared. I don't really like the way that looks. So I'm going to write y squared is equal to x plus 6. Well, now I just got to find y. So I take the square root. Now, one of my flashcards, oh my God, there it is again, flashcards. One of my flashcards says, if you take the square root, what do you got to remember to put? And the answer is a plus or a minus. So the inverse function is y equals plus or minus the square root of x plus 6. Now, even this would not get you full credit because it said find this. And you got to put it back in the proper notation. F inverse of x equals plus or minus the square root of x plus 6. Done. This problem's a beast. So what we're going to do, the denominator is a mess. It's got a parentheses. I'm going to try to get rid of that parentheses here first. Let's take care of that first. The numerator, I'm not going to play with. We'll talk about it in a minute. And I think there's some flashcard implications here. So what I have here is 2 to the negative 2. I'm going to talk about what that means in just a minute. When you have an exponent raised to an exponent, when you have an exponent raised to an exponent, you multiply the exponent. So this becomes x to the negative 6. Again, negative 7 times negative 2 is y to the positive 14th. Now here's the kicker. If it has a negative exponent, negative exponents make fractions. But if it's in the denominator, it comes to the numerator. If it's in the numerator, it comes to the denominator. So these things are all going to move. So I'm going to end up with 2. Now when they move, they become a positive exponent. So 2 squared times 3 times x to the 6, because that 6, this one went up, times y to the 5th. Now notice the y's aren't moving because they have positive exponents. That x to the 4th is coming down, and I have a y to the 14th down there. Now once I've done this, the rest of it's all but history. My number is 12. The numerator has 2 more x's, so that's x squared on top. And the denominator has 9 more y's, so I end up with y squared on the bottom, y to the 9th on the bottom. Now, when you're done, it would be absolutely foolish of you not to check to make sure you have this right answer. Because if I can check this and say, start it, don't have to look at it again, and then you can say, Mr. Krause rocks, right on your test, everywhere you see a test, right? Mr. Krause rocks, and your graders are going to be like, what are they talking about? What's he talking about? Why is he doing that? Mr. Krause rocks, problems bodied. Bodied means done, dead, finished, complete. So here's what we're going to do. We're going to do this real quick. We already have a number in for x and y. I don't remember what it is, but I know I stored a number in for x and y. So I'm just going to type this in exactly as it appears. Control division, 3x raised to the negative 4, y raised to the 5, all over, parentheses, 2, x to the negative 6, x raised to the negative 6, parentheses. No, it's not x raised to the negative 6. It's x cubed. X cubed. Let me change that. Got to put exactly what the original was. X cubed, y raised to the negative 7, parentheses. That whole thing, oops, in the wrong place. Got to get out of the parentheses. That whole thing raised to the negative 2 power. Now make sure when you press enter, it looks exactly like it does. See, look at this. Make sure, ooh, man, that's freaking weird. Okay, that's a weird answer. I may want to change my x and y. I may want to make y smaller, but as long as I end up with the exact same answer, who cares? So 12, control division. If I end up with that same exact answer, we're going to be good. 12x squared over y raised to the 9th. Oh, look at that. Exactly the same. Perfect. Done. Start it. We have an alert.
It's a flashcard alert. Flashcards. Do you know your flashcards?
I don't know if I told you, you can get flashcards. They're for free. One of my flashcards says, what happens when you see this? What do you do when you see that? Do you remember? I hope you do. If you don't, go to your counselor. Go sign up for summer school. Be like, Mr. Krause told me I was supposed to study. And I'll be like, who's Mr. Krause? I don't know. He's some bald guy that just pissed me off. It's better to be pissed off than pissed on, though, isn't it? That's what I always say. My flashcards tell you, if you remember, if you see this, you do f of negative 3 first. So the first thing we're going to do is do f of negative 3. All right, we'll just plug that in. Plug in using parentheses, negative 3 squared minus 6. This is 3. Now, if you don't trust yourself to do that right correctly, then come over to your calculator and do negative 3, control var x, and then type in x squared minus 6. It takes a little extra time, but you get it right. Now, whatever we get, we're going to plug into g of x. So whatever we get, now we plug into g of x, g of 3. Oh, that's 2 cubed minus 1. Well, 2 cubed minus 1 is 7, but if you don't trust yourself, check it. All right, here we go. Now, I had a bunch of kids mess this up on a problem because they kept trying to add 10 to everything. What this is 10 plus all of this summation stuff. So what are we going to plug in first? We're going to plug in a 1. 1 cubed minus 1. Well, that's just 0. And then it's 2 cubed minus 1. 2 cubed is 8. 8 minus 1 is 7. Then it's 3 cubed minus 1. 3 cubed is 27. Minus 1 is 26. Then it's 4 cubed minus 1. 63. 5 cubed minus 1. 124. So if I add all this up, I don't know what that is. 124 plus 63 plus 26 and 7, 26 plus 7, enter, and then plus 10 at the end. So this ends up being 10 plus 220 or 230. My prime problem was my kids kept adding 10 to everything else. Kind of dumb. Now, that you have to show work for. You have to show that work, but how dumb would it be not to come over here and go, okay, we'll go to sigma. We'll go 10 plus, and we'll go in our sigma notation, enter, n 1 5 n cubed minus 1. N cubed, get out of exponent mode, minus 1. Star it. Mr. Krause rocks. Below is the graph of the function f of x. And then the question down below says state the domain and range. Okay, so domain, by the way, if you just do this without saying what they are, you're wrong. So you have to write domain. You could write D, domain. Now you have to do it either in interval notation or in inequality notation. Now remember, domain are the x values. So we look, what's the furthest left I go? Furthest left I go is 1, 2, 3, 4, 5. So bracket, -5, comma, 1, 2, 3, 4, 5, 6, 7, 8. 8, bracket. Range. Now don't be that dummy that uses those points as the range. The range of the y values. The lowest y value is right here at 1, 2, 3, -3. And the highest y value is right here at 2. And there you go. That's it. Now, if you didn't use interval notation or you don't know interval notation, you could have done -5 is less than or equal to x is less than or equal to 8. And here, -3 is less than or equal to y is less than or equal to 2. Since these are both under radicals, I can simplify them right away. So I'm going to do 108 divided by 6. 108. I'm hoping it goes in. It does, by the way. 18. So this is the square root of 18. There's more x's on top, so that's x to the 4th. There are more y on top, so that's y cubed. Now, if you remember correctly, earlier I said it takes 2 y's to get 1 y out. If I had the square root of y to the 4th, that gives me y squared. Every 2 of these gives me 1 out. Okay, so that's what I'm going to do here. I have a 4th. That's not a problem. Let's take care of the 18 first. The perfect square that goes into 18 is 9, so it's 9 times 2. X to the 4th is a perfect square, so I'm going to leave it. But y cubed is not. Y cubed I'm going to rewrite as y squared times y. And I'm going to come through with my other colored pen. Square root of 9 is 3. The square root of x to the 4th is x squared. The square root of y squared is just y. Now I just write 3x squared y. And what did I not cross off? I didn't cross off this 2, and I didn't cross off this y. Now, again, I'm not going to go through this. Actually, I can. It takes me 2 seconds. Control division, probably a minute. The square root of 108 x5 y8. X raised to the 5, y raised to the 8. All over the square root of 6xy to the 5th. 6x times, this calculator makes you, if you put an x and a y next to each other, it thinks that's a variable. Xy to the 5th. Enter. Oh, crap. Let's see what x is. Oh, x is -3. We can't have x equal to -3. So take 2.1. It's always a good idea to redo those. 2.1, we'll store it into x. I can't have a negative number under radical. Gives me imaginary numbers. 2/3, whatever, who cares? And then I'm going to type this in. 3x squared times y times the square root of 2y. 2y. Same answer. Bodied. All right, so here's one where they said we have to use sigma notation, but I'll be... Okay, so what we have to do here, now this one's a kind of a tricky one. I mean, you could kind of cheat around this one a little bit, but it's easy not to. First of all, we're adding 7, adding 7, adding 7. It's an arithmetic sequence, so my formula is going to be a sub n is equal to my first term, which is 7, plus n minus 1 times 7, because 7 is my common difference. Now I have to figure out how many terms I got to go to get 105. Now that's where I said you could just keep cheating and hopefully you get there. But I could just say, okay, 105 is equal to 7 plus, and then I'm going to distribute this 7. 7n minus 7. All right, the 7's cancel. And I end up with 105 equals 7n, or n equals 15. So I know there's going to be 15. This is the 15th term. Now you could have just kept adding and say, okay, I know there's 15 terms. But it said using sigma notation. You got to use the sigma notation. N equals 1 to 15. So I needed this to get that number up there. And then I'm going to use my arithmetic sequence formula. 7 plus n minus 1 times 7. Come over to my calculator. I go sigma, baby. N. The only thing I hate about this is typing this all in. 1, but it's easy. 15. I needed to get that 15. I got it. Don't use those parentheses. By the way, if you ever end up with huge parentheses around, start over. Sometimes you get like these ginormous parentheses around the E. You got to start over. 7 plus parenthesis n minus 1 parentheses 7. 840. Oh, I never finished it. Oh, it didn't say find the sum. It said express the sum. Well, I guess this is the answer right here. All right, let's keep going. Here we're going, another circle equation, right? So it's just going to ask the formula of the circle. So we know that the center goes in with opposite signs. So it's x plus 5 plus y minus 3, opposite signs, squared is equal to the radius squared. So the radius squared is the part. Remember, don't pick just some stupid point like this because that doesn't work. You can't say, well, that's about 5.5. You don't know. We've got to find this. This we're going to call R. So we just make a right triangle. 1, 2, 3. You know, try to make an accurate right triangle, not like my crazy drawing here. This is 4. This is 4. So it's 4. So 4 squared plus 4 squared equals R squared. 16 plus 16 is 32. Stop! Remember, R squared is what goes here. So we just put a 32. That's it. Use the discriminant to determine all values of k that will have this equation equal roots. Equal roots. If the discriminant is equal to 0, that's the only time you'll have equal roots. Guess where I know that information from? Alert, 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 flashcard, alert, flashcard, alert. One of my flashcards says is if the discriminant is equal to 0, what do you know? Oh, you know the roots are equal. If you know that fact, this problem's not that bad. If you don't know that fact, guess what? Problem's impossible. Well, basically impossible. So the discriminant is b squared minus 4ac. K squared minus 4 times 1 times 4 equals 0. Okay, I'm going to set it equal to 0. So this is k squared minus 16 equals 0. Oh, I just have to factor. K minus 4, k plus 4. So my two answers for k are plus and minus 4. Start it. By the way, you can always come over your calculator. Man, that can bother. Find the sum of the roots. Sum of the roots. Oh, all right. Sum of the roots is negative b over a, negative b. Write the formulas. Every time you do these, write the formulas. Negative b over a is negative 11 over 5. Done. Product of the roots. Write the formula. C over a is equal to negative 3 over 5. Done. The graph of this equation has one asymptote. So I really shouldn't have to do this, but let me go over here. Go into graph mode. And I'm going to type in parentheses, control division 1 over 2 raised to the x. And there's what it looks like. So your graph should look like this. We all know it's an exponential. It's going through that point. And then probably what you ought to do is copy down the table of values, x and y. If you looked at the table of values, if you had typed in a negative 3, it would be 8. If you type in a negative 2, it would be 4. Negative 1, it would be 2. 0 would be 1. 1 would be a half. 2 would be a fourth. Now, I can also come over here and look at the table just so you know I'm not lying to you. There's negative 3, 8, negative 2, 4, negative 1, 2. Just come over and look at the table of values. There it is. So I know that it's going to be negative 1, 2. negative 2, 4, negative 3, 8, and then a half, and then a fourth, and then a 16th. So here's what it looks like. So the first thing they ask you to do is graph it. Please, please, please make sure your graph hits there and be accurate. And the asymptote is right here. An asymptote is a line that it's going to almost cross, but not really. So what is the equation of this line that it's going to get really close to but never touch? That line is y equals 0. And that's the answer to the question. Express in simplest radical form. Remember, if we have a square root, it takes an x squared to give me 1x. So for every 2 x's, I can take 1 out. So I'm going to rewrite this as 5 square roots of 3x squared x minus 2. Now this is a 9. This is got a perfect square in it. So it's 9 times 3 x squared times x. I'm just going to rewrite it as perfect squares and not perfect squares. What is the square root of x squared? It's x. So this is 5x square roots of 3x minus, this is 3, and this is x. So this gives me 6x square roots of 3x. 5x minus 6x is negative x square roots of 3x. Again, this is one I can star if I want to. I come over here and I say, okay, 5 3x cubed. 5 3x cubed. Oh my God. If you don't have this calculator, 3x cubed. I mean like the calculator one. 3x cubed. It goes pretty fast. You can actually do these really fast. Minus 2 square root 27, see, I don't know, 27x cubed. Hit enter, you get that. Now type in our answer. Negative x square roots of 3x. Bodied. Done. Check everything you can check. Oh, we're at 4-point questions. Good time to take a break. Okay. All right, 3 questions. One of which sort of belongs here, sort of doesn't belong here, but this is a 4-point question, so it's going to require a little bit of work. It says use the recursive sequence to find the next 3 terms. Not 3 terms, but the next 3 terms. So we're going to start with a sub 1. A sub 1 is equal to 2. That's our first term. So now we got to find the next 3 terms. So a sub 2 says 3 times the previous term, which is 2, raised to the negative 2 power. If you just type that in your calculator, it will tell you it's 3/4. Just type it in, believe me. Remember, negative exponents make fractions, so this really just takes this thing and puts it in the denominator. A sub 3 says take 3, multiply it by the previous term, 3/4, and raise it to the negative 2 power. Well, if you do this, it will tell you the answer is 16 over 3, right? Yes. And then you got a final term is a to the 4th equals. Now, again, I'm doing these in my calculator. I'm just going to go over here and do this in my calculator. I'm going to go 3 parenthesis 3 divided by 4 parenthesis raised to the negative 2 power. It'll tell me it's 6. Of course, I didn't take the number. Negative 3 power. And it tells me negative 2 power. Oh my gosh! It's been a long day, kids. Been a long day. I'm going to show you an easier way to do this one anyway. Tell me 16 over 3. And then I'm going to do 3 times. Remember, recursion is just doing something with the previous term. 16 over 3 to the negative 2 power. And that's 27 over 256, I think. I think that's the right answer. 27 over 256. And there it is. There's the next 3 terms. Now, again, you can use your calculator. For recursion, it's really, really nice. You just press in 2, you press enter. And then what does the direction say? It says 3 times answer. You got to hit answer. You can't hit the up arrow. You have to hit answer. Raised to the negative 2 power. 3/4, 16 over 3, 27 over 256. You just keep going. There it is. Now you're in crazy land now. Uh-oh, we got a tough one. Okay, so this is right binomial expansion. I'm only going to do one of these. They come up every once in a while. If you don't know how to do binomial expansion, come over to my homework. Come over here. Go to Regents Math. Now, Regents request by topic. Do I have binomial regression? I don't think I do. Or binomial expansion. It's not one of these, is it? So it's not, it doesn't come up very often, and that's why it's only got one term. But you can go to this topic review, and I do have binomial expansion in here as well as binomial probability. So you can click on these notes right here, and somewhere in here is some binomial expansion. There it is. I've got 3 examples right here of some binomial expansion for you. So you can go do a little bit of practice with it if you need some help practicing with it. But here's how I do it. And I don't know how your teacher taught you. They might have taught you using Pascal's triangle. I can't stand that method. But if you do that, you might want to go get help from your teacher on that. I use combinations. It's 5, choose 0, 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, and 5, choose 5. Again, you could use Pascal's triangle 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. If what I just wrote to you here doesn't make any sense, ignore it. Pretend like I never did it. That 1, 5, 5, put this in your calculator. I don't need to do this, but I mean, I know these memorized, but I'm going to go menu 5, 3 again. That's menu. 5 is probability, and 3 is combinations. And I'm going to put in 5, comma 0. It's 1. If I put, I'm only going to do a couple of these. If I put in this one and I change it to a 1, it's 5. Then this would be 10. This would be 10. This would be 5. And this would be 1. Okay, next to each of these, I'm going to put 2 sets of parentheses. By the way, if you search YouTube for binomial expansion, I have an entire video dedicated to binomial expansion on there. I don't have the notes that you can print with it. In the first one goes 2x. In the second one, that's the first one, goes minus 1, negative 1, negative 1, negative 1, negative 1, negative 1, negative 1. And now we do our exponents. You start with 5, 5, 4, 3, 2, 1, 0. This you start with 0, 0, 1, 2, 3, 4, 5. And now what you want to do is type in all the things that are number. You want to type in a 1, you want to type in a 2 to the 5th, and you want to type in a negative 1 to the 0. So just come over here. 1 times parentheses, it's not negative 2, it's positive 2, right? 2. Now I don't type in the x, raised to the 5th. And I am going to do this negative 1 raised to the 0. You'll see why in a second. This is just 32. So what I end up with is 32x to the 5th. Now I'm going to type in all these numbers. So I just hit this up arrow. Now this is going to change to a 1. This is going to change to a 4. And this changes to a 5. Negative 80. Negative 80 x to the 4th. Now we just do it again. This changes to a 2. That's why I put the negative 1 to the 0 in there to begin with. This changes to a 3, and this changes to a 10. 80. 80x cubed. By the way, this is a 4 here. The next one, do it again. Binomial expansion is sort of a pain in the neck, but whatever. It's not difficult. It's just a pain in the neck. 2 and 5. Negative 20 x squared. The next one is just going to be 10x, and the last one is going to be minus 1. Just for fun. But it said write as a polynomial in simplest form. So I got to actually write it out as a polynomial. So you just take those suckers and you put them next to each other. 32x to the 5th minus 80x to the 4th plus 80x cubed minus 20x squared plus 10x minus 1. All right, we're on the last problem. Oh my God, it's so exciting. But it's a 6-pointer. Now, I could have put this one with the factoring or the quadratic or whatever, but I chose to put it here because it was just a weird question. It's not too bad, but it's not too nice either. So this is the last problem. This is the last problem. Oh my gosh, I'm so excited. Then I get to go to rest and maybe have some dinner. Draw a rectangle. We have a rectangular deck that measures. It currently measures 14 by 22. Now the building code, because there's always people that have building codes, want to say that the area has to be less than. Oh wait, it just says it can't exceed, right? Allows for a deck to have a maximum area of 800. So that means less than or equal to 800. The homeowner wants to increase the number of width and length by the same amount, increased by the same number, there it is right there, by the same number, so that he does not exceed building code. So we're going to increase this by the same amount. So we're going to add x. We're going to add x to both of these. Well, all right, so how do I find the area of a parallelogram or a rectangle? You take the base and you multiply it by the height. And we need this to stay under or equal to 800. We just don't, not exceed means less than or equal to. So now we got to double distribute. We get x squared plus, oh, this should be 14. Sorry about that. I think that's 392. I'm just going to, 308. X squared plus 22, 36, x plus 308 has to be less than or equal to 800. I subtract the 800. I get x squared plus 36x minus 492 is less than or equal to 0. Now you could try to factor this, but this really wouldn't be a 6-point question if this was factorable. So I'm going to use my calculator menu. 3, 3, 1, enter. 136, 136, negative 492, negative 492. It's clearly not factorable. One of my answers is going to end up being negative 46, and the other one's going to be 10. So it's not factorable. Clearly it's not. So we're going to have to use the quadratic formula. Not bad. So we do this. We go x equals negative b over 2a. Oh, I wonder if this is a
Flashcard alert, flashcard alert.
You have to have the quadratic formula memorized. It is not given to you. It's me whining about those flashcards. I can't stress them enough, kids. I really, truly can't. I mean, if you believe everything I said, get those flashcards and start studying. A equals, B equals, C equals, and D equals. Now, D for us in my class stands for the discriminant, b squared minus 4ac. I like to do that math over here. A is 1, 36, negative 492. So I'm just going to do what, I don't know what 36 squared is. 36 squared, 1296. So 1296 minus 4 times 1 times negative 492. So minus 4 times 1 times negative 492. And I enter some big number, 3264. Well, I'm almost done. I'm almost done. This was actually a really easy a 6-point question. So you get x equals negative 36 over 2 times 1 plus or minus the square root of 3264 over 2. Well, I just got to figure out what that's equal to. Well, I've already done the math. I mean, I've already done it, but you have to type in your calculator. So just to make sure that we did it correctly, make sure you did the quadratic formula correctly, you're going to do control division, negative 36. I don't know how much time do I do press that. Negative 36 over 2. We'll hit the plus, control division, the square root of 3264. Does it again. $32.64 over 2. And we end up with 10.5657. So x equals 10.5657. Good enough. And then if we do the minus, which is going to turn out completely useless, but that's okay. Let's come down here, just hit the minus, delete, minus, and I hit enter, I get negative 46.56. No, negative 46.5657. But you can't have a negative length, so that answer doesn't make sense. Now here's the dilemma. What do I do with this? The question says, find the maximum number of whole feet that I can, so now they want you to round it. Here's the problem. If you go over this, if you round it up to 11, which you're inclined to do because of this right here, you'll be wrong. So the answer is 10 feet. That's it. It was fun, kids. I'm sure I'll have more. By the way, if you need something more, if you want something more, I've got lots of videos of lots of places. But if you need more practice, come email me. Let me know. I'll try to do the best I can. I'm very, very busy. Got a lot of stuff going on in my life, but I'll try to help you out and hook you up, okay? That's it for tonight. Catch you on the flip side. Good luck. Keep studying. Listen. Hit the subscribe button. Hit the like button. Hit the donate button. Not donut. I don't need any more donuts. I mean donate. But I really, truly hope that you do well on this test. I hope you crush this test. I hope you rock this test. And please spread the word. Tell your friends. Put it on Twitter. Hey, check Mr. Krause's videos out. Helps you out a little bit, okay? All right, guys. Catch you out. Flip. Bye.